In this video, I would like to talk about conservation of momentum. Just like conservation of energy was a very, very powerful principle, simple but powerful principle to predict the future, conservation of momentum is also an incredibly powerful principle that allows us to make predictions. And in fact, this one simple principle of conservation of momentum has allowed us to crack a lot of puzzles about the universe. And it's also something that many of life's creatures employ in order to propel themselves, as we'll see later in the slides. So I'm going to start by reading this here. Like energy, momentum must be conserved during a collision. This means that in any collision or explosion, the momentum of all bodies before must be exactly equal to the momentum of all bodies after, right? So just like we had that for conservation of energy, E1 must equal E2, okay? We now have that the momentum before a collision of all objects, right? The total momentum of all objects in a collision, right? Sometimes there's just two, and sometimes there's many, okay? Must equal the total momentum of all the objects after a collision, okay? And another way to say this is momentum before, right? Some people like to say momentum before must equal to the momentum after, right? And the before and after is before and after a collision of some kind. And it's important to know that in physics, a collision is defined either as two objects approaching each other, like this, right? Or, and obviously smacking together, or some object that was originally whole, then breaking apart. Okay? In either situation, so in this situation, these guys would collide and then go in separate directions, right? In either situation, the momentum before must equal the momentum after. And the momentum here before must equal the momentum after here. And so, like, for example, this means here, if this guy's at rest, right? This is just a little ball at rest. That means that the momentum of these two pieces as they shoot off in different directions must add up to zero, because the momentum of this after the collision, the explosion, must equal the momentum of this ball just resting there before the collision.